Hello everybody, welcome to Lab 6, a review of solving quadratic equations. Standard form of a quadratic is y is equal to ax squared plus bx plus c. We always want to be sure that we write our terms in descending order, which means that the term with the highest degree will be first and they will decrease from there. Quadratics have a degree of 2, so they will have two x-intercepts. When we are finding x-intercepts, we set y equal to 0. So we actually are solving equations of the form 0 is equal to ax squared plus bx plus c. The zero factor property tells us that if we have the product a times b, and that product is equal to 0, then either a equals 0 or b equals 0. We will use this zero factor property in order to factor and solve our quadratic equations. Our first example is the product of x plus 4 times x minus 6. That product is equal to 0. Based on our zero factor property, we want to set each factor equal to 0. So our first factor, x plus 4, is set equal to 0. Then to solve for x, we subtract 4 from both sides, leaving us x is equal to negative 4. For the second factor, x minus 6, we also set that factor equal to 0. So we are solving the equation x minus 6 equals 0. We add 6 to both sides and find that x equals 6. That tells us that our solution set for this quadratic is negative 4 and 6. For our second example, we have the product of the factors 3x minus 5 and 6x plus 2 equal to 0. Again, using our zero factor property, we want to set each factor equal to 0 and solve for x. Our first factor, 3x minus 5 equals 0. To solve for x, we're going to add 5 to both sides. That gives us 3x equal to 5. Then divide both sides by 3 to isolate x, and x is equal to 5/3. And then our second factor, 6x plus 2 set equal to 0. To solve for x, we subtract 2 from both sides and have 6x equal to negative 2. Then divide both sides by 6, leaving us x is equal to negative 2/6. We want to write this in simplest form, so divide the numerator and the denominator both by 2, and we have x is equal to negative 1/3. So our solution set is negative 1/3 and 5/3. When we are given a quadratic that is not already factored, we will need to factor it. Factoring is the simplest and quickest way to solve a quadratic, but do remember that not all quadratics will factor. Some basic rules when we are factoring anything is to always first look for greatest common factors. If there is one, go ahead and take it out. Then look at the number of terms that you have. If you have 2 terms in your quadratic, look for the difference of squares. If there are 3 terms in your quadratic, try to factor using some of the basic trinomial factoring methods. Here is a site that I like. Try to look at it and see what you think. Here's our first example of a quadratic that is not already factored for us. We have x squared plus 5x plus 4 equals 0. First, notice that we have 3 terms, x squared, 5x, and 4, in this quadratic. Also notice that the coefficient in front of x squared is a 1. Since it is a 1, we need to focus on the factors of 4. The factors of 4 are 4, 1, 2, and 2. Since the sign in front of the 4 is a positive, I know that the signs in my binomial will be the same. Since the sign in front of the 5x is a positive, I know that the signs in my binomials will both be positives. Then I need to look for factors of 4 that sum to give me a 5. Well, 2 and 2 give me 4, and that's not right. So I need to look at 4 and 1. And it turns out that 4 plus 1 is 5. So my quadratic will factor into the binomials x plus 4 times x plus 5, and that's set equal to 0. Then to find the values of x, I take each factor individually and set it equal to 0. So the first factor is x plus 4 equal to 0. I subtract 4 from both sides, and I have that x is equal to negative 4. The second factor, x plus 1 equals 0. To solve for x there, I need to subtract 1 from both sides. So x is equal to negative 1. That gives me a solution set of negative 4 and negative 1. In this example, we again have a trinomial, x squared minus x minus 6 equal to 0. Notice that the lead coefficient, the coefficient in front of x squared, is 1. Also notice that now we have a negative in front of our 6 and a negative in front of our x. The negative in front of the 6 tells us that the signs within our factored binomials will be opposite. So we will have one factor that looks like x minus, and the other factor will be x plus. Then we need to look for factors of 6 that have a difference of 1, since 1 is our coefficient in our second term. The factors of 6 are 6 and 1 and 3 and 2. 6 and 1 have a difference of 5. 3 and 2 have a difference of 1. So we would want to use the factors 3 and 2. That will give us factors of x minus 3 times x plus 2 equal to 0. Be sure to always go back and multiply the factors to make sure that you get your original quadratic. Then we set each factor equal to 0. X minus 3 equals 0. To solve for x here, we're going to add 3 to both sides, and x is equal to 3. The second factor, x plus 2, equals 0. To solve for x here, we subtract 2 from both sides, and we have that x is equal to negative 2. So our solution set is negative 2, 3. In this example, notice that our lead coefficient, 2, is different than the previous lead coefficients of 1. In this quadratic, 2x squared minus x minus 3 equals 0 needs to be factored in a way where we consider the relationship between the lead coefficient 2 and the constant 3. So the first thing we want to do is set up our binomials. So the sign in front of the 3 is a negative. That tells me that the signs within my binomials will be opposite. One will be a positive and one will be a negative. Then we need to consider the factors of the lead coefficient 2, which are 2 and 1, and the factors of the constant, which is 3. The factors of 3 are 3 and 1. Now remember that they have to interact in a way such that the middle term, the second term, has a coefficient of 1. We're going to try a couple of options. It turns out that our factors will be 2x minus 3 and x plus 1. This is called the trial and error method. You might have to try a couple of different arrangements of the 3's and the 2's in order to come up with the right factors. So always be sure that you are checking using multiplication. We take each factor then and set it equal to 0. So we will have 2x minus 3 equals 0. To solve for x, we add 3 to both sides and have 2x is equal to 3. Then divide both sides by 2. So x is equal to 3/2. And then we set our second factor, x plus 1, equal to 0. To solve for x, we subtract 1 from both sides, and we have that x is equal to negative 1. So our final solution set is negative 1 and 3/2. In this example, notice that we only have two terms. We have 6x squared plus 7x equals 0. If we remember that our quadratic in standard form is ax squared plus bx plus c, you'll notice that actually c equals 0. So we have the greatest common factor of x that we are able to factor out of these two terms. When we take the x factor out, we're left with x times 6x plus 7 equal to 0. We still want to set each of the two factors equal to 0 to solve for x. So when we set x equal to 0, we simply have x equals 0. Then we want to set 6x plus 7 equal to 0. To solve for x here, we subtract 7 from both sides, which leaves us 6x equal to negative 7, then divide both sides by 6, leaving x is equal to negative 7 over 6. Our solution set here is then negative 7, 6, and 0. In this example, again, we have two terms, x squared minus 1 equal to 0. Notice that these are actually the difference of squares. X squared is a squared term, and 1 is a squared term, and they are being subtracted. When we have the difference of squares, remember that they will always factor into the first plus the last times the first minus the last. So we have x plus 1 times x minus 1 equal to 0. We set each factor equal to 0, and we have x plus 1 equals 0. Subtract 1 from both sides, and x equals negative 1. The second factor, x minus 1, equals 0. To solve for x there, we're going to add 1 to both sides and have x equals 1. So our solution set for this quadratic is negative 1, 1. In this example, we have a trinomial again. We have x squared minus 10x plus 25 equal to 0. Notice that 5 squared will give us 25, and 5 plus 5 will give us 10. This is called a perfect square, and perfect squares will factor into the same binomial twice. To find that binomial, look at the factor that gave you the 25, and in this case it was a 5. Then look at the sign in front of the 10. It's a negative. That tells us that the sign within both of our binomials will be negative. So the two binomials that we have are x minus 5 times x minus 5 equal to 0, or x minus 5 quantity squared equal to 0. Since we only have one unique factor, we set that factor, x minus 5, equal to 0. To solve for x, we add 5 to both sides, and x is equal to 5. The solution set for this perfect square is simply 5. For additional information and help, please contact the Pensacola State College Math Lab or your instructor. Have a good day.